Okay, everyone, thank you for joining us today for today's webinar, MURB EV Charging Laws, What Developers Can't Ignore. I'm Julie, and I am the marketing coordinator here at Electric Avenue. For our agenda today, we will start with the EV charging landscape and what's driving change, then look at tenant expectations and upcoming compliance mandates. We'll cover smart infrastructure planning, monetization, and timing your rollout, and finish with a case study on J2K's property success. And with that, I'm happy to introduce our speaker today, Mark MacDonald, founder and president of Electric Avenue. In 2001, a newly graduated Mark MacDonald thought he was set for life when he landed his dream job at Nortel Networks, the largest company in Canada at that time. 1 year later, after failing to respond to disruptions in the industry, the company was on the path to bankruptcy, and Mark was jobless. Witnessing a tech giant like Nortel fall due to the lack of foresight and action was all Mark needed to take his future into his own hands. In 2003, he started his first business designing and installing home automation systems, which he sold 3 years later. For the next decade, Mark honed his technical problem-solving skills to help engineers, developers, and electricians design and power spaces all over Atlantic Canada, which led him to merge two companies in 2016, forming Catalyst Sales and Marketing. In 2018, he started a renewable energy company, and in 2021, founded Electric Avenue, an electric vehicle charging company that sells both hardware and software. Today, he sits on the board as the Strategic Alliance Chair for the Atlantic Canadian chapter of the Entrepreneurs Association. He also serves as a Sustainability Energy Advisor on the Community Council for Vida Living, a developmental company raising the standard of affordable rentals in North America. While his dream job may not have panned out the way he thought, it did set him up in ways he never could have imagined. Mark credits Nortel for teaching him an invaluable lesson about business and life, to never rest on your laurels and that the status quo is never the option. Before we get started, if anyone has any questions throughout the webinar, feel free to put them into the chat. We will address them at the end of the presentation. Thank you so much, and I hope you all enjoy.
So I know this is a presentation about the future of transportation, but I don't think we can look at the future of transportation without looking at the past. This is not our first generational environmental transportation crisis. In 1894, the London Times dubbed this the Great Manure Crisis. They predicted that in 50 years, every street in London would be buried under 9 feet of manure. And it wasn't just London, it was all major city centers at the time. Despite fierce debates amongst urban planners, various studies into the matter, no solution was ever found. It was actually a disruptive technology that saved the day. It was Henry Ford, it was Carl Benz, it was Daimler, and others that introduced motorized vehicles at a massive scale and the internal combustion engine. It wasn't the first time a better technology saved an industry, and I will argue the exact same thing is happening now with our global transportation system. So what does 100 years of innovation get you in the mass-produced automobile and the internal combustion engine? Well, it gets you this. This is the peak of that technology. Some would argue this is the Bugatti Chiron. It does 0 to 60 miles per hour in 2.3 seconds, and you can get this for the low price of $4.7 million. In just over 10 years, this is what Tesla has brought you. This is the Model S. This is their top-end version, the Model S Plaid. It does 0 to 60 miles per hour in 2 seconds. It runs a quarter mile in 9.3 seconds. It has a top speed of over 320 kilometers an hour. You can drive 600 kilometers on a single charge. You can add 200 kilometers of range in 5 minutes of charging on the new fast charging network V4. It even has a boat mode if you get stuck in a flash flood, and you can get all of this for just $150,000. So why am I telling you all this? Because the EV charging landscape although it may be nuanced and regional in people's belief in its adoption and its long-term adoption rates, the data and the numbers are pretty conclusive. If we look at the US and Canada over the last 4 or 5 years, you can see this exponential growth curve. This is the sales numbers. So last year we hit 1.2 million EVs sold in the US. We were over 250,000 in Canada. Now this is just number of units sold. You see a drop in 2024 in the Canadian number, and that is due to the fact that all vehicle sales were down in Canada last year. But if we look at the percentage share of new vehicles sold combustion versus electric, you can see that same growth curve continue year over year in both the US and Canada. And if we look at 2024 specifically, I mentioned Canada is going through an economic slowdown, so all vehicle sales were down. It still represented almost 15% of all new vehicles sold in Canada in 2024. Just under 10% in the US. So the growth is still phenomenal, but it's still underpacing the global market. So as much as I just mentioned, a lot of our opinions or perceptions on EV adoptions are tied to the region we're in or the country we're in, the global trend is even stronger than what we're seeing. And that is the point that I am trying to make, that this is here to stay. So I know we have a mix of people on this call, from developer to engineer to distributor to contractor, but I just want to reassure you the numbers will continue to increase, the adoption rates will continue to go up, and everything I'm going to tell you, there's some sensitivity to it, but the growth rates are here to stay. How quickly we adopt is probably the only thing in question. If we look at the rental market and we go back to the crux of this presentation, we're seeing a growing EV charging gap in the rental market. 33.1% of Canadians rent their homes, 35.8% of Americans rent their home, and it's almost 30% in both markets that live in a multi-unit residential building, which is classified as 3 units or up. As soon as we get into those multi-unit scenarios where we're moving from tenant metering systems to house metering systems, the infrastructure requirements change significantly, and that's what we really want to focus on today. For anyone on the call of their own interest, those hot spots for rental markets right now: Montreal, Vancouver, and Toronto. Some common names you would see in the Canadian market, and then Miami, New York, and San Francisco would be the highest rental markets in the US. So for anyone involved in the decision making around infrastructure in these buildings, what are tenants' expectations? So what is the feedback that we're getting from the rental market? Now, some of this is going to be weighted in the market itself and its vacancy rate. We just hear it anecdotally in our own business what the interest from developers are in deploying infrastructure because of, one, their vacancy rate. If you're sitting at less than 1% vacancy, which means you turn over the unit 30 days after it's exited, some of the amenities we're going to focus on here may not be a deciding factor. But if we look at the market overall, 30% of renters say they would not rent a unit if it didn't offer access to EV charging, and that's up 15% from earlier in the year earlier in this survey. And if we get a little deeper, more than 50% of millennial and Gen Z renters considered EV charging as an important or desirable amenity. So depending on where you are at in the spectrum of the multi-unit residential space, these stats will matter to you if you're chasing these type of renters in your building. Something else we have to consider when we're talking about EV infrastructure, specifically in multi-unit residential buildings or single-family homes for that matter, is an electrified transportation system should look nothing like this. This is your internal combustion engine. This is our current transportation system in North America. This is a horrible use case for an electrified transportation system. The last thing you want to do is run your battery down to zero like we do with our gas cars, stop at a gas station once or twice a week, fill back up to 100, and do the same thing again, because that use case is not ideal or valuable for a whole lot of reasons that I'm not going to focus too much on with an electric vehicle or with that electrified transportation system. This is a photo I took, actually. I rented an EV last time I was in Florida. This was me waiting for some Electrify America chargers at a mall outside Kissimmee, Florida, in Orlando, outside Orlando, sorry. And this is a lineup to get on the fast charger. And this is why the experience doesn't make sense. One, we don't have enough fast charging infrastructure to service the needs of all those EV drivers we just looked at in previous stats. And two, cars sit 96% of the time and they're not moving. So there's ample opportunity to be plugging into chargers. But if we go back to that stat we just looked at with 30+% of North Americans renting their homes, they don't get to decide if there's infrastructure there to support them. Other benefits are the slower you charge the car, the better for the battery and battery maintenance. So fast chargers are not ideal in that application. Also, cost to deploy level 2 chargers, which we'll talk about a little more, are significantly less money. So there's a whole lot of reasons tenants of multi-unit residential buildings, expectations are that they come home at night and they're going to be able to plug in and charge that vehicle. That is the ideal scenario for an electrified transportation system. I get to my destination, whether it's home, work, a shopping center, the golf course, doesn't matter where it is. I plug into a charger, and when I go to leave, my battery's topped up and ready to go. And I never get into situations like this where I'm waiting in a lineup. So 2025 compliances and EV-ready mandates. So these are construction codes to right to charge laws. Compliance isn't just coming, it's already here in certain states and certain provinces. So let's look at EV-ready versus the right to charge and what the difference is. EV-ready essentially refers to building code requirements. How many parking spaces must have conduit, wiring, or, so that's pre-wired, what we would consider pre-wired, or even energized outlets to support future chargers. These are what developers are required to build into new or renovated properties. Right to charge laws, on the other hand, empower individual tenants or condo owners. They give the people the legal right to request charging access and make it harder for building owners or HOAs to say no to that request. So that's the significant difference between EV ready and those right to charge laws. So who has EV ready mandates now, depending on what province or state you're currently in? This could be applicable to you, but we have 11 states with EV ready mandates and 3 provinces, and you can see the mix here. At the national level, Natural Resources Canada is currently developing a standardized EV ready code for Canada through the National Building Code, which should soon apply in Canada nationwide once that is finalized. And EV ready mandates. So let's take a closer look at EV ready mandates. Typically, they require buildings to have conduit, wiring, also known as your electrical raceways, running from the electrical panel directly to the parking spaces, significantly reducing future installations costs, because really at that point the only thing we need is the endpoint device, the EVSE, or what we would call the EV charger. They also specify adequate electrical panel capacity to support practical and efficient level 2 overnight charging. Mandates usually define a set of percentages or number of parking stalls that must be either EV ready or fully EV installed upon occupancy. These numbers vary so widely depending on adoption rates, not only at the national and state levels, but at the municipal level and really regions within those municipalities, depending on EV adoption. In Canada, British Columbia leads, requiring 100% of residential stalls in new multi-unit buildings to be EV ready. This is the most aggressive mandate we've seen. Cities like Vancouver, Burnaby, Richmond, they have even stricter local bylaws in place. Quebec also requires EV ready infrastructure for new homes, with plans to extend requirements to larger buildings by the end of 2025. In the US, California, a no-brainer here, mandates 10%, and they lead the way, 10% of parking spaces in new multi-unit buildings have chargers fully installed, with another 40% of those parking spots EV ready. Washington states at 10%. You got cities like New York, with their own local EV ready laws, such as Local Law 130. Key takeaway here for everyone, EV ready mandates aren't on the horizon, they're already here, and the momentum across North America is quickly accelerating. And for anyone doing work in this space, I think the precedent set by some of these mature or higher adoption markets like California, BC, and Quebec really can set the precedent for how you're designing or wiring or ultimately building your buildings today. So right to charge laws, which states and provinces have those? Well, you see that here, 16 states and 2 provinces. So the 16 states, 2 provinces. For property owners and developers on this call, this means the regulatory pressure is no longer just coming from government mandates, it's actually coming from the tenants themselves. So instead of it being at the federal, or in these cases, the state, provincial level, it's coming from those tenants. Ignoring these laws can lead to legal disputes, project delays, or even forced compliance through tribunal or court orders. It's a growing liability, and as people adopt these vehicles, you're going to see more and more pressure where these right to charge laws exist, and one that is completely avoidable with a proactive plan in place. Load management and smart charging infrastructure planning. This is probably one of the most critical from a planning perspective. So EV charging isn't just about plugging it in, it's about understanding how EVs refuel conceptually, what equipment is required, and how to scale it intelligently and cost effectively. So we'll just break down a few of the nuances related to this. I just want to start with the basics of EV charging because, again, I mentioned it, but there's a broad array of people on this call, and as far as where they land in the channel. So first, let's look at the EVSE itself. That stands for Electric Vehicle Supply Equipment. So when I say charger, when the common term for these things are chargers, technically that's not true. When you get into level 1 and level 2, which we're looking at here, level 1, these are considered electric vehicle supply equipment because it's AC from the electrical system on the building, it's AC into the vehicle. The charger or charge controller actually resides in the vehicle. It converts the AC to DC to feed the batteries. So if we look at level 1 charging, a couple things to speak on quickly on this and why we don't see it deployed in multi-unit residential practically. Level 1, always 120 volts, always single phase. The problem is you're only getting 5 to 8 miles per hour, 8 to 12 kilometers an hour. So when you get into these large load balance systems, or when you want to add load balance systems, you want to add billing and monetization, these are really like the spare tires in your vehicle. They don't get you very far very fast, and they don't have the technology built in them to do a lot of the load balancing and billing and monetization protocols or OCPP protocols we want to run. So not really practical. It comes with most vehicles. It's really a worst case scenario. The other reason is just the range. You look at the top 10 vehicles now in North America, you're talking 300 to 500 miles of range at the top end on a single charge. So we just need more power practically than what level 1 can offer us in a lot of these situations. Level 2, this is really the only thing you need to focus on or know about from a multi-unit residential perspective for a whole lot of reasons. But level 2 always equals 208, 240 volt. It's always single phase. We'll just keep it simple. It's also AC from the electrical circuit, and it's AC into the vehicle. It relies on the charge controller of the vehicle. But what you're starting to see here is a bump up in power, of course, and with more power comes more range in a shorter amount of time. So we're talking anywhere from 15 to 60 miles per hour, depending on the size of the EVSE and also the charge controller in the vehicle, or 24 to 100 kilometers of range per hour. The reason this is the sweet spot, I already mentioned it, 96% of the time your vehicle's sitting there not moving. That means, on a level 2 charger, we probably only need 1 to 3 hours, depending on certain variables, of charge time per night. So a level 2 charger is going to do the job for almost everyone out there every single time they come home and plug in. And with those data points, the average American only drives about 30 miles a day. Now we can start loading even more chargers on the same circuit, which we're going to talk about shortly. And the last charger you may hear referenced used to be called level 3. The way I remember it, level 1, 120, level 2, 208, 240, always single phase. Level 3 was always 3 phase, 208, 480, or 600. We now call level 3 DC fast charging. This is actually charging or a charger because we're converting the AC to DC in the unit. But now you're going from $3,000 to $5,000 for a level 2 charger, all the way up to $100,000+ for a fast charger. You also have to install these larger ones outdoors. Tenants don't want to cycle and wait in line like that image you saw earlier. So they're just not practical for a whole lot of reasons. Also service size, additional service size requirements, wire size, just physical location on site. There's a whole lot of reasons we don't see these in multi-unit residential, but they're out there. These really should be the non-destination infrastructure. So I leave home, I make it to work, I make it to the mall, the golf course, the movie theater, whatever it is. And the only time I really need to stop on these fast chargers is when I can't make it from point A to point B. Connectors, so level 1 and level 2 in North America, there's either two types of connectors. I'll just try to simplify it and not bore you with all the acronyms. There's the J1772, which is the non-Tesla connector for level 1 and level 2, and then we have the Tesla connector, which is now the NACS connector, which then became the J3400, but you can just refer to it as the Tesla connector. You see these two cross-sectionals here. Pinouts are actually the same, it's just a different physical layout on level 1, level 2. Then we get into DC fast charging. CHAdeMO we don't need to talk about. That was a Japanese standard, which is really gone now in North America for all intensive purposes. We have the CCS. So this is the non-Tesla fast charging connector. We call it a combo connector. It's got the J1772 up top and your DC plus minus for your fast chargers on the bottom. The reason the Tesla connector has done so well, one, it's designed so it's the same connector for level 1, level 2, and fast charging. And then two, just the abundance. Tesla invested so heavily in their fast charging network. Many manufacturers and OEMs want access to that network. So that's why you're probably hearing, if you haven't heard already, that people are moving to this connector as the standard on their vehicles. And now that it is an open standard, not proprietary, we're all moving our hardware in that direction as well. The good news or unfortunate news is there are adapters for every type. So really 4 adapters you need in North America if you remove the CHAdeMO. So any vehicle can charge on any charger. Now that has a bunch of asterisks to it, but simplistically, that's how it works. So smart load management for the engineers on the call, and we go back to those requirements, the right to charge laws and the EV ready laws. How can we do this in the most cost-effective way? I mentioned 30 miles, 50 kilometers a day roughly is the average drive distance. So we only need a couple hours of charge time per night. How do we maximize our electrical services or keep the cost down when designing new electrical service to be able to service or serve the needs of those tenants? The most critical way is smart load management. This is covered extensively in both the newest revisions of the National Electrical Code in the US and the Canadian Electrical Code here in Canada. For the NEC, it's Article 625, 625.42. that specifically cover EVEMS, Electric Vehicle Energy Management Systems. And for the Canadian Electrical Code, you'd refer to Section 8 and Section 86 for what I'll share with you next. This is the most common way. There's multiple ways to do it, but this is the most common way that you would load balance. So the electrical code requires you, if I put one 48 amp charger on one dedicated 60 amp branch circuit breaker, I need to add 48 amps of demand to that building or that load calculation. Now, if I parallel 4 chargers on the same 60 amp circuit, I've gone from one 48 amp charger to 4 48 amp chargers, but I've only added 48 amps of demand if those chargers can communicate either wired, wirelessly, or cloud-based or locally. So what that allows me to do, first car plugs in, pulls 48 amps. We're going to keep it simple again. By the time I get to the 4th car, they're each pulling 12 amps. So this is what we would call a single phase branch circuit load share. These 4 chargers are paralleled off the same branch circuit. This is the most cost-effective way to do it. It's not the most functional. If you wanted to get the most functionality, because typically what an electrician would do in that branch circuit scenario, they would put the 4 chargers side by side. 2 people come into that building, let's say I have 20 chargers, they're the only 2 using the charging network, but they're side by side, they're load sharing when theoretically, there's still room on that service for them to have full 48 amp draw on both vehicles. That's where this becomes more common, more money from an infrastructure standpoint, but a better use case for the drivers. This would be a panel level load share. Now, I mentioned these chargers are single phase, but of course, multi-unit residential buildings are primarily 3-phase systems. So this is a panel level load share on a 3-phase 208 volt panel. This is actually a visualization from our back end. Now we can connect chargers to phase A, so rotation AB, phase B, rotation BC, and phase 3 or phase C, rotation CA. And now, excuse me, instead of overloading the branch circuit at that 4-to-1 ratio, I can overload the main on the panel at that same ratio. So now I'll put 800 amps of charging load, use up all those circuit positions in my 208 volt panel, and I'll overload the main from 200 to 800 amps in that same 4-to-1 scenario. Where this becomes even more valuable from a design, engineering, and cost to deploy perspective is when we do a multi-level load share. So now we're actually going to protect the panel or a group of panels. This is a pretty common layout for a multi-unit residential building. I've got my main switchboard here. I've got a secondary transformer fed from that main switchboard. Then I have multiple panels or a dedicated EV transformer and dedicated EV panels feeding all of the parking spots in that building. Now I can put a hard cap on my 4-to-1 load share on the breakers on each panel, but I can also protect the secondary transformer. So I could overload both in this scenario on the odd instance or really far down the road when we're starting to get a bunch of demand on the chargers on that building. So I can actually protect both. We call this a multi-level load share, where there's a transformer protected, but also the individual panels are protected, where this practically is the most valuable and what the NEC now recognizes. So I mentioned before, one charger equals 48 amps of load added to the building. If I do a 4-to-1 load share, I've only added 48 amps with 4. If I put an energy monitoring system in place that can communicate with the charging loads and throttle them to 0 during peak times or peak service demand times, then I can 0 rate the EV charging loads in the building. So now as an engineer, I can take an existing multi-unit, I can add 100 chargers, and I don't have to bring in a new service. I don't have to do complex load calculations. Now I'm simplifying this. Obviously, some of this work would still be done as far as calculations. But what this does, we go up to our kit, others do it. Our kit goes up to 5,000 amps on a 3-phase 208, 480, or 600 volt service. And why this works so well is because all of the EVSE, the chargers in the building, we always know how much load they're drawing because they have current transformers built in. What we don't know at any point in time, what are the elevators, fire, house power suites, all the secondary transformers or anything connected directly to that main switchboard, what are they drawing? So we put the CTs right on the main switchboard on the secondary of the utility transformer, and all we do is compare in real time. What's my charging load demand current-wise? What's my building load? And we'll throttle up and down accordingly. And why it works practically is because these buildings are built no different or see no different demand response curves than what you would see on the grid. People come home at night at 5, 6, and 7 o'clock in their apartment buildings. They plug their vehicles in, they turn their TVs on, their lights on, their stoves on, their dishwashers on, their dryers on. Building loads are high. But as you start going to bed at 6, 7, 8, 9 o'clock at night, building loads drop, and what we do is throttle up charging loads because we talked about it many times now, but I only need a small charge window. So if I'm a tenant and I come home and plug in, my car gets 0 amps or 0 kilowatts of power. But when I wake up in the morning, if my vehicle's back to 80 or 90%, I don't really care about that experience because ultimately I only paid for the kilowatt hours I needed, and my car is back to the level of charge I wanted to. So that's the value, short-term and long-term, in these load management systems. So a huge cost savings, I mentioned it several times, but it lowers your install costs. You can put more chargers on the same panel. You could avoid triggering those utility upgrades. Most utilities in most markets won't even let you bring a second service in at the same voltage. And you can cut your install costs anywhere from 30 to 70% compared to unmanaged setups. This number is probably even higher. Cost savings, there's a lot of incentives and subsidies. Even despite the administrative change in the US and policy changes in the US, we still have funding out there at the federal and state levels that needs to be used up. So we can get you more details on those per state. And then for the developers on the call, and ultimately the tenants as well that you're trying to solicit or appease, EV charging is revenue generating. So it is an amenity, but it's also a revenue generator for those developers. You can build the tenants, you can build visitors, you can use time of use pricing structures, you can also use penalty fees if they don't turn the spot over, you can have reservation fees. So all of these charges that are getting tied to house meters do have a monetization scheme associated with them. The role in software, so all of us, I'm speaking on behalf of Electric Avenue. The nice thing about this industry now is that technology has been standardized. We all use the same OCPP communication protocol. Most of us now are open source, so the hardware and software is interchangeable. But the role of software really in monetization, controlling the access, monitoring, billing. We talked about load balancing and just demand response ready, and also being ready to integrate with a lot of these utility programs that are going to lower cost on energy if they can communicate with your charging loads in your building. So that's the beauty of software. This is what it looks like for the drivers to start sessions. This is what it looks like for the site host or those developers who host the equipment. Determining the long-term value, we also have a wonderful ROI calculator tool if anybody wants to use it. Of course, the numbers, sometimes are difficult to predict, but apartments are actually one of the easier numbers to predict an ROI on because the industry, including us, have really good data points on ROI and utilization within apartment buildings, but typically 3 to 5 years payback in apartment buildings, depending how much you deploy and how close you are to matching the current demand in your apartment building for the tenants with EVs today. The life is typically 8 to 12 years of these things. Timing transition, so some strategic considerations. Equipment selection, we already talked about. Level 2 charging is all you're going to worry about. This is for overnight use, and you just want to make sure it's scalable. We talked about open source quickly, how you're going to network the hardware, energy supply capacity, so knowing your existing panel limits or knowing your existing transformer limits more critically, and then what load management is needed. Site assessment, placing chargers, one, where they're easy to access for tenants, where you keep the initial cost down, getting as close to the electrical panels as you can, and then also considering pre-wiring for future proofing. Charger specifications, the nice thing about us and most manufacturers now, we only really sell 2 versions of level 2, 48 or 80 amps. So for engineers on the call, you can select what amperage makes sense for that panel. We still see a lot of EV ready requirements at 32 or 40 amps on the EVSE side. So you can just tune these chargers down mechanically, which is also recognized by the code, without having to size the branch circuit based on its total capacity. System voltage, we already talked about it, 208 is going to be 98+% of what you see in multi-unit. Connector types, we're still J1772, so non-Tesla is the most common we're seeing until vehicles other than Tesla actually start getting built with the NACS connector. And future-proof, what type of upgrades can we do at that site? Another key consideration for anyone involved in the design of this equipment for multi-unit is connectivity. Wi-Fi, cellular, or LAN. We also have a no network option where we can actually just process payments off the driver's phone. So ideally, your LAN or you have good cellular coverage, right? Wi-Fi would probably be the 3rd best option. And then if none of those are an option, you can also do payment processing through the driver's phone. So no network connectivity required. Also, when you're selecting hardware, what you'll see commonly specified or, in markets that are more mature in this, you want to make sure the chargers are compatible with OCPP 1.6, 2.0.1, also the ISO 15118 standard, which is plug-in charge where it can get credit card and user info from the vehicle. Also CTAP compliant, which on any chargers with LCD screens where they provide feedback on billing and energy usage in real time. Supply capacity. Energy supply capacity, utility service availability, this is critical. Do you have enough capacity to start with? Distance from the power source for voltage requirements and voltage drop. And is it 208 or 240? And we always want single phase with center tap transformers. So no floating grounds when you're speccing out single phase transformers on this equipment. Civil and structural work considerations, if they are going outdoors, foundation requirements. There's a lot of company that's built great precast products now to support pedestals and chargers. There's also great directional boring products out there from companies like Southwire to allow you to save costs on a lot of the trenching and civil work that's needed. And ultimately protective bollards, you want to protect these mechanically like you would any critical piece of equipment. Site layout and design, number of chargers, this varies so much. We're happy to work with anyone in any market to determine the best case, or what would meet some EV ready plan requirements, or what would future-proof that building. Cable management, we always recommend, similar to your air hose at your gas station. You don't want these cords laying on the ground. They are expensive to replace. Key signage and marking, accessibility, lighting, these are all critical pieces of the puzzle. So creating an EVSC policy, really, we'll work with you on this as well. This is a great starter pack we have, but set clear expectations. You want to support that right to charge compliance, and ultimately you got to plan these buildings for long-term scalability. If you're not doing it now, I can assure you, especially on the engineering side, these developers are going to come back and ask why in a year or two when they go to deploy this infrastructure and it hasn't been designed accordingly, not only for today, tomorrow, but long-term as well. Just a quick success story to close out. J2K Properties, one of our favorite developers we've worked with. They started with just looking for 2 chargers. They're a smaller regional developer, just over 1,200 doors under management. They're only looking for a few chargers. This goes back almost 4 years to support a few tenants that had just bought EVs. We worked with them on some funding through the federal government in Canada. We secured them some funding. They went from 2 chargers to 112 chargers. We developed quickly our multi-tier load management to support them so they could overload not only the branch circuit but the panels themselves. So we built out that multi-tier to support their demand, and now they have over 10% of their total parking stalls EV ready today, so you could charge a car in them today. Impact and results, it was great. Increased visibility for tenant and public use. So really the goal of that ZBIT program and a lot of programs was to change tenant perception. So now when people pull in their parking stalls, they're like, oh, they've got 12 unused chargers down here. Maybe my next purchase can be an EV. It's had that effect in these buildings. Their average age of rental is almost 65. So these tenants are here for a lot longer, and they care about this infrastructure when they're deciding what vehicle they're going to drive. Also, a lot of visitor parking, so it was great visibility for the public use. They generate quite a bit of revenue. They actually bill visitors at a higher rate than their tenants, and they're also now future-proofed with the load management systems as they go to scale up their infrastructure. Just closing out some helpful tools. You're going to get all of this in a follow-up email, but our ROI calculator is online. It is available for free at no charge, so you can see what type of return on investment that would get you at your multi-unit site. Also, that starter pack I referenced, so it simplifies EV charging requests with a building policy. So we'll get that starter pack over to everybody. And with that, just questions. Is there any questions? I know we covered a lot in a short amount of time, but that was the goal, to give you as much information as we could, to give you lots to think about. Julie, how are we doing questions? Is there a chat?
Yeah, there are no questions currently in the chat, but yeah, if anyone has any questions, they can put them into the chat and I can read them to Mark.
You can also leave them in the chat and we can throw out answers when we send out the follow-up email with those resources that I just referenced. Okay, perfect. I think we're close to time. Anyway, if there's no questions now.
Yeah, we will make sure a copy of the recording will be sent out along with the policy starter pack and a link to the ROI calculator. Yeah, if you have any questions or would like to get in touch, feel free to scan the QR code on the screen. Thank you so much for attending.
Ken gave me a clap. Thanks, Ken. Maybe it was for Julie, actually. Julie was talking, so we're not sure. Thanks, John. Thanks. Thanks, everybody. Oh, yeah, Dawson. We know Dawson. Heather, condo boards. I will say, Heather, I see your comment there. Condo boards are one of the most difficult organizations we've ever seen EV charging deployments, like to get across the finish line with. Yeah, there's a lot of cooks in the kitchen. Dawson has something there. Manitoba is dealing with a guy. Right, yeah, Dawson, that comes up. New Brunswick, pretty much all the US and most of Canada allows you to bill per kilowatt hour on level 2. We're actually approved under Measurement Canada's temporary dispensation ruling for level 2 on our hardware. But we can get you that, Dawson. I will make a note. But yeah, provinces can still supersede Measurement Canada's mandate on kilowatt hour building and still force you to bill per time. But our software allows you to bill for both. The problem is if you bill for time on level 2, especially on a load share, one, everyone's paying the same amount regardless if they're getting the same amount of power. And two, if you have a 48 amp charge controller versus my plug-in hybrid that only has a 16, we're paying the same amount per time, even though, I'm getting almost a quarter of the energy. But yeah, we'll get something over to you on the Measurement Canada ruling, Dawson. All right. Thanks again, everybody. Have a great day.